Guarda che bello.
Detto là. Spesso si vedono neri o
Bellissimo.
verde oscuro, per così dal sole possono prendere subito il calore.
Come fanno a capire?
Non so cavallo. Underwater as nymphs, like this stage, eventually they will come out and hatch into adults. Okay, I leave you this one to share. So, let's check what's around. Very few birds at the moment because it's the end of the wintering period, but there are still breeds. Let's see. There is this white bird, Egretta garzetta, the little egret.
In fondo.
Yeah.
What?
Una garzetta. Little egret. Like this one.
Due ce ne stanno. Si è buttata, fatti il tubo.
Ah, sì, là in fondo l'ho vista. Ah, sì, sì, sì. La mia bianca là in fondo.
Ah, eccola. Uguale. Con quel beccone.
Sorry?
Ah, mi scordo tutto. So, look, yesterday we were speaking, I was telling you, I was all the time telling you about the clay, no? I was always saying the clay, yes? Yeah. I was mentioning the clay a lot. So, in Malta we have these five, I don't know if you can, if you want, I have another set. So, here you want? So, look, in Malta you have five different layers, all right? Yesterday we were speaking, what we were seeing. You remember when we walked up the road? Some of you, I was showing you the fissures, no, in the rock. That was the upper coralline limestone. Okay, so that was the upper coralline limestone. So now when we walk a bit more, what you're seeing up here is the upper coralline limestone. All right, and this has as you could see in the rock is very porous. It's very porous. All right, when it's all right. Tutto bene? Yes. So, yesterday I was telling you that when it rains, the water is going to pass. Basically, the rock is very porous. It's also very permeable. When we say porous I don't tell me if you poroso, huh? But we say porous and permeable. Huh? So this rock is very porous. 40% is air. So it has a lot of air, okay? But it's also very permeable. So basically, as you saw yesterday, there are a lot of fissures in the rock. And the water moves down quite fast, all right? Till it gets to the clay, all right? Till the clay. That was in Rabat. So Rabat is that way, all right? So two ridges that way. Over here, there are two faults. There are two faults. So tectonic. Falte. So these are faults. So basically, this lower coralline limestone has been pushed down. So over there, up there, you have the upper coralline limestone and the clay underneath. Okay. There's a fault, and then over here, what you're seeing up there as upper coralline limestone is now at the bottom of the valley. Okay, it makes sense? So the clay here is a few meters underneath the fields. Does it make sense, or? Huh? So what I want to say is that when you have the sea water, okay, so when you have so the island of Malta, so if you have the island of Malta, so you have around Malta, obviously there's seawater, okay? In the pores of the rock in the center of the island, you have fresh water. There's fresh water which is floating. So basically, if this is Malta, this is Malta. Basically the water is going down into the rock, all right, in the pores of the rock, and at the very bottom you have seawater. There's the seawater, okay? So this is water in the pores, okay? When it rains and the water percolates to the rock, you create this freshwater lens, basically fresh water floating on seawater, okay? And what you have here is this. Over here, the bottom is clay, so there's clay at the bottom, but there is the sea. So the sea is also coming in above the clay, and there is fresh water which is like floating above the seawater. Does it make sense? Yes. If it rains, I will move another page. So when we pump, as we walk, there will be some holes, okay, where they pump water. So the farmers, so over here, this is good soil. So here there is, because it's a valley, no, you have sediment coming from the higher areas into the valley. And you also have this aquifer which is above the clay, but it is a bit in contact with the sea. So the thing is that I will go back one step, sorry, because I wish to show you one other thing. Coming. So I want you to understand that. So if this is the sea level, okay? This is the level of the sea, all right? And this is Malta, okay? And that is Malta. So when it rains, the water is coming in, and it forms this aquifer, okay? So basically, the water comes in, it forms. There is a layer above the mean sea level, but there's also a layer below the mean sea level, okay? So this is fresh water, and so this is fresh water, and this is seawater, all right? So the fresh water is floating on the sea, okay? Now, the salinity of fresh water is much less than seawater. Yesterday we said the fresh water is about 1,000 or 2,000 milligrams if we speak about the minerali in the water, okay? If you evaporate all the water and you leave the minerals in the fresh water, you have about 2,000 or 3,000 milligrammi per liter, okay? In the sea, you have 40,000. So, 40,000, 40,000. So over here is 4,000 or meno, or less, or less. And this is 40,000. So you can imagine this one weighs much more than this, okay? So so we have a relationship that for every 1 meter, if you have 1 meter above, so this is the level of the sea, okay? for every meter above the level of the sea, we have over here, we have 30. Because I wish to show you one other thing. Come in. So I can give you. So I want you to understand that. So if this is the sea level, okay? This is the level of the sea, all right? And this is Malta, okay? And that is Malta. So when it rains, the water is coming in, and it forms this aquifer, okay? So basically, the water comes in, it forms. There is a layer above the mean sea level, but there's also a layer below the mean sea level, okay? So this is fresh water, and so this is fresh water, and this is seawater, all right? So the fresh water is floating on the sea, okay? Now, the salinity of fresh water is much less than seawater. Yesterday we said the fresh water is about 1,000 or 2,000 milligrams if we speak about the minerali in the water, okay? If you evaporate all the water and you leave the minerals in the fresh water, you have about 2,000 or 3,000 milligrammi per liter, okay? In the sea, you have 40,000. So, 40,000. So over here is 4,000 or meno, or less, or less. And this is 40,000. So you can imagine this one weighs much more than this, okay? So so we have a relationship that for every 1 meter, if you have 1 meter above, so this is the level of the sea, okay? For every meter above the level of the sea, we have over here, we have 34 metri. So for 1 meter above the mean sea level, we have 34 meters below the mean sea level, okay? So actually, it is a lot of water. Now, if a farmer comes and he drills a hole, okay? And he takes this water, basically he puts a pump on here and takes the water out, okay? So this level goes down. So if this level goes down, so if this level now is
Not a meter.
half a meter,
Okay.
this one now is half. All right, so basically, if you pump too much, this one comes up. The seawater comes up. Make sense?
Yes.
And this is
Difference of pressure.
because of difference in pressure. It's by weight, and basically.
Dynamic fluid.
The thing is that this over here, now we have mixing of the fresh water with the seawater. And this is what we call seawater intrusion. Seawater intrusion. You have seawater intrusion at home?
Yes.
You speak a lot of. So what we have here is a problem of if you pump too much, the seawater comes in. Now, we have the marsh, the wetland, all right? The wetland. Now, so the seawater here is 40,000, okay? If you heard him, this is 40,000. In the marsh, in summer, it's 200,000. 200,000. 200,000. So you can imagine that actually the marsh is also affecting the groundwater behind. Make sense or no? So if you understood him, he said that when it rains, water goes into the thing and mixes with the water and pushes down the salinity. But if it doesn't rain, so yesterday we said we're getting less rain. It's getting less rain. So now this water in the marsh is always above 40,000. It's always as high. I mean, it goes to sometimes in winter it goes to 32, but it's a lot. It's nearly seawater. So why am I telling you this? I'm telling this because there is a connection. There's a strong connection between how much water is being pumped by the farmers, how much it rains. So if it doesn't rain, the farmer takes more water. So if the farmer takes more water, more seawater basically intrudes into here. So there is a lot of these connections. So the farmer needs to grow food. So it's important. The farmer needs to grow food. This wetland is a habitat for a lot of species which, if that was not there, don't exist. So like the killifish, the fish he was talking about, that is the national fish of Malta. It's a very special fish. Basically the birds which come here, a lot of them eat this fish. In summer, when it's 200, when the salinity is very high, the fish die. You heard him say, basically, when the salinity starts going up, they lay their larvae, they lay their eggs, and they die. And then when the salinity goes down again, the larvae hatch. So there's larvae for the next year. But there are what I want you to think about is there are a lot of connections. There's a lot of connections between water for the environment. And so here there's a forested area, where they need to irrigate. Okay, so so this is a bit about the groundwater here. But if we walk 10 minutes in this road, there is the wastewater treatment plant. So there is the impianto, the what do you call it? Depurazione. This plant here basically takes all the water. When you were coming with the bus, with the autobus, there is St. Paul's Bay. There's a big village. All the water from there and basically from Rabat to here, all comes here, okay? The important thing about, let me stop here, and now we walk a bit more, and I will explain a bit more further in. It's good or no? Or you want to walk? Come we walk a bit more. If you tell my wife, I hate the camera, and you are all the time with the camera. So I want over here. So over here we have the north wastewater treatment plant. Okay, so all the wastewater of the north of Malta comes here. Okay, but this plant is quite important because so you do something about wastewater treatment in class about trattamento dell'acqua, depurazione.
Yes.
You know what is in wastewater? You know what is in wastewater? What is in wastewater?
Human waste.
But what is it? What if you talk about water quality? What is inside? Water. It's
Yes,
wastewater.
that's water.
So 99% is water.
pH.
Number one.
pH.
Huh? What else?
Plastic.
Minerali.
Minerali.
Yes. So you have salts in the water because you add them in soap and all of this. Yes. What else? Solids. Solid. Plastic. No, you don't throw plastic in the side. You have so basically the wastewater has organic matter, materia organica, see?
Yes.
Nutrienti,
Yes.
nitrogen and phosphorus, and it has solids, and there are solids in the water. There are solids. So the process of wastewater treatment. I wish we went inside, but they don't let people at the moment. The process of wastewater treatment is first they let the water. Ortona is the same, okay? So the process of wastewater treatment is generally the same.
Yes.
Okay? But when it comes in the wastewater, first there are screens. There's like a mesh, and in it you take off the nappies, you take off the cloths, the big things. Okay? So first you take off the big stuff, and then at the back, I don't know, maybe if we go up you can see there's a big round tank. And the water stays there to let the solids, but also the organic matter to settle. Okay,
Yes.
so basically and they take the water from the top. So basically the water at the top is the cleaner water, and the solids we call it the sludge. And the sludge is pumped out. Okay?
Fango.
Il fango, perfetto. And then from the sludge it goes into another tank where they pump air. So basically it's like
Ossidazione.
Ossidazione. So there's bacteria. There's a population of biomass of
Sì.
bacteria, which need oxygen. So it's an aerobic process. So basically, they're pushing air with what you hear. This is blowers. They are pushing the air into the water. Okay, and this bacteria consumes. Important is the organic matter. It
Yes.
consumes the organic matter.
Dissolve the organic matter.
The dissolved organic matter. Perfect. So that is it. So over here, and then basically they put it in another tank and they separate the organic matter from the water. Again, they let it settle.
Yes.
And then in one of the other buildings, our wastewater is salty. It has a lot of minerali, because people throw high salt waters into the water. Okay. So this water, if is too salty, has too much salt for agriculture, so you cannot after the settling, after the biological process, there is too much. The water has nutrients, so it has some nutrients still in the water. The organic matter is removed. It has very little solids, but it has quite a lot of salt in the water, and this is not good for agriculture. It's too much. Okay. So here they pass it through a process of reverse osmosis.
Yes.
They push it through, and this I will speak about reverse osmosis on Friday with
Yes.
you. Okay. But here they pass it through reverse osmosis, and basically they take out all the salt. So all the salt is concentrated. All right.
Yes.
And I thought you wanted to jump in and dive, to swim. But it's not a good idea over here, because here there is the outlet of the concentrate. So all the nutrients.
Nitrati.
So it has a
Nitrati.
lot of. So it has a lot of. In the water, you have still organic matter, a bit of organic matter, but you could have bacteria because it's not. So that then is discharged into the sea.
Ok. Brutto
So
però.
here, it's treated water. Now another thing is that this area here is a sensitive area. There's Posidonia.
Yes.
Posidonia. So
Posidonia is a very important for the ecosystem
of the sea.
Yeah.
Exactly. So over here is a protected area because
Okay.
of Posidonia. All right.
Okay.
So of the 3 plants in Malta,
Yes.
the 2 plants in Malta, 1 in Gozo, this one needs to also remove the nitrogen. So the
Yes.
nitrates here in the
Nitrates.
big plants of Malta, it's not into a sensitive area, but this one is a sensitive area.
Yes.
So here they have to basically, the process is a bit different, to basically remove the nitrate
Yes.
and convert it into nitrogen gas. All
Just by the
right? By basically they have anaerobic, they have different
no
processes
by the process of
basically it's an anaerobic process. So basically it is no air. They have it's a batch.
anaerobic. Yes.
So basically they have a different type of bacteria which doesn't use oxygen in the water but consumes the nitrate and the and organic matter.
Yes.
And organic matter. But this is our over. So then the water passes through a reverse osmosis process, and as we walked on the road, there were hydrants. The raw water, the wastewater, okay, comes into a tank, all right, and they let it. So this is the tank at the back. Over here there's a screen. The water passes through a screen, and they take away nappies, pads, and all the stupid thing people throw inside. It gets stuck here, all right. Then it goes in a tank, all right. And it's allowed to settle. So basically, the fungo goes to the bottom, and so it has organic matter, and they take the water from the top. So basically, they take the water from here. Okay. So that is the first. We call it the primary treatment process.
Yes.
To remove organic matter, a bit of organic matter, and solids. All right. Then it goes to another tank, and here we put oxygen.
Yes.
In the water, okay? But this tank, it works in a batch. Sometimes they put oxygen, sometimes they don't put oxygen.
Okay.
And here they remove organic matter and nitrogen.
Yes.
All right? From here, from here it goes into another tank. And it goes into another tank, and the fungo, the biomass from here settles, and they take the water again.
Yes.
So they take the water from here.
Purify.
This water, is good to throw to the sea. Can go to the sea.
Yes.
But over here, then it passes through ultrafiltration first.
Yes.
So basically, it passes through a membrane, a piece of plastic.
Yes.
So a piece of plastic with very, very small holes.
Yes.
With a
Filter.
0.04 micrometer.
Okay.
Meter.
Yes.
So the pore size.
10 alla meno 6.
The pore size is 0.04.
Yes.
So the dissolved minerals pass through, but any solids stay.
Yes.
Okay.
Of course.
So this is your ultrafiltration.
Okay.
All right. And then after this, it goes to reverse osmosis. RO. So after ultrafiltration, it goes to reverse osmosis, and in the inverse osmosis inversa. Here, basically, now it concentrates the salts, and so basically you have a membrane. So this is water comes in, it passes through. It's pushed for reverse osmosis. You need a pump, a big pump.
Yes.
And it's depending on how much salt is in the water.
Yes.
You need to increase the pressure. Okay. For seawater, so we said the seawater is 40,000 milligrams per liter.
Yes.
All right. This water will be like 5,000 milligrams per liter. Okay. So this one, the pressure should be about 60 bar. 60 bar. You know how 60 bar?
Yes.
If you shoot 60 bar up, you know how high it will go?
Yes.
For
Atmosphere.
For every bar, 1 bar is basically the water goes up 10 meters. So 60 bar, is 600 meters. So if you so it's a lot of pressure. You need to put a lot of energy into the process. Okay, but here the pore is even smaller, and over here the product, so the good water comes out. So normally we say here 70% if 100 liters. If 100 liters go into the membrane, okay, 70 liters. So if 100 liters go in, 70 liters go out. And here there is no minerals or very little. And the 30 liters
goes in the ground.
This one, the 30 liters, has all the minerals which was originally here. And this goes to the sea. Okay? So if you don't remove the nitrogen over here there'll be a lot of nitrogen, which is bad for the Posidonia. Make sense or not?
Yes.
Be careful, man.
No, però Marti, pure tu che ti del cavallo.